Hey y'all, I've made a bunch of videos on electrical engineering and engineering in general, my own theory on artistic engineering and making everything human human friendly and creative. They would call that like the human factor. We actually had a book we had to study in first year that was called The Human Factor. And then I advanced it into artistic engineering. So it's like you're designing, but you're using science and arts, and you're like making it sleek and intuitive and advanced and high tech and easy to access, quick to use, and stuff like that. So basically, it was like like you gotta have a brain. Like it's like designing. You need the brain to design, right? So you need a brain to design. You need to have the knowledge and the expertise to design. But then, who you are designing for, you can design like a bridge or like a telephone, like a battery, right? But if it's something that a human's going to use, you need to design for a brain. And that's where the artistic side comes in. So it takes a brain to design, but then when you design for a human, you you design for another brain, and that's where the artistic side comes in. Um, but and so I did a lot of videos on that, and but I never did programming because I'm a good programmer. But what was always bugging me down was I never understood the hierarchy of coding. What that means is I know how the program is designed. I know where the logic is. I know what calculations is doing and basically how it's thinking. So I know how codes and programs and video games and security and databases, I know how they're thinking. But I never understood the logistics, the like how to upload a website or how to create an app or how to connect to the internet or how to access the memory and the RAM and the camera. And I figured out these are called, you go into Microsoft Copilot, and the question I asked is first, I found out it's called an API. And I've come across the term API many times before because when you start programming, the first thing you got to do is download an API. So you cannot program without an API. So there's two things you need to program. First, you select the language. Okay, you select the language. The language dictates the syntax. What does syntax mean? Syntax means the language, the words you're using. For example, int is short for integer. Rand is short for random. Whether you use round brackets, square brackets, semicolon, asterisk, what do you actually have to type in as letters and characters to instruct your uh, code to run? Now, that's a language. Common ones like HTTP, HTML, Python. Python is the simplest one because it's not really a language. It doesn't have any complex syntax. It's more just like start typing the commands. You just start typing the commands in Python. But it's used everywhere because it's so simple. More complicated ones are C++ and Java, which can do like I guess algorithms and stuff like that, and functions and different objects and classes and stuff like that. We'll get into that. So you got these more complex ones like Java and C++, and you got simple ones like Python and JavaScript. Now, where it's going to run, right? So if you're coding a website or an app, you're going to use JavaScript. It's compatible everywhere. And if you're coding for Android, you can use Java. If you're coding for iOS, that's only the exception. iOS uses Swift exclusively. I don't even know what the fuck Swift is. iOS uses Swift. So the language, C++, Java, Python, those are the ones I would learn and that I know. In school, we studied C, C++. You got C#, Java, JavaScript, Python. Let me see what other languages are there. What are common languages? JavaScript. So look, the first four it spit out was JavaScript, Python, Java, C#, and then C++ and Swift. I don't know what the fuck Kotlin is used. So Kotlin, you can use Java for Android, and you can also use Kotlin, something new, for Android. TypeScript is a form of JavaScript. So TypeScript is a form of JavaScript. What the fuck is Go? Golang, is cloud services. And SQL is databases. So you heard of SQL? SQL is databases. What is a database? It's where your memory is stored. For example, you take a user password, you take a username, you take the character stats, you take their settings and whatever, and you take that, which is okay. But then you got millions of users, so you got to store all that data. So you can't just fucking create a new string. A string is a word, so you can say store password in a string. That's true. But then you don't just store a password in a string in the code. You take that string and you send it out to SQL. And SQL encrypts it, encodes it, and files it away in a database. And then you can play with your database for all your data. So SQL does databases. So once again, the languages, I know all of them except for Kotlin and Go. Go is for cloud. Kotlin is another form of JavaScript for Android. Other than that, the other 8 were SQL, TypeScript, JavaScript, Swift for Android, C++, C#, regular C, Java, Python, JavaScript. Now, let me just tell you what a tech stack is. You may have heard the term tech stack. What a tech stack is 4 things. Your front end. So your front end is where the buttons and the screens are and all of that is. That is your design, what you see. That's your JavaScript, C#, C blah blah blah, Swift, Kotlin. Okay, regular programs for the front end, and the back end uses also these kind of regular programs. Go, the cloud, is on the back end. Python, Java. Okay, so kind of the back end and the front end kind of use the same. Back end and the front end kind of use the same programming language. Just one interacts with what the user, buttons, keyboard, mouse, and data, and the other one handles passwords and authentication and I guess the calculations. So you got your front end, back end. This is for the tech stack. You got your databases, SQL, and you got your infrastructure, where it runs. Google Cloud, Azure, AWS, Vercel. I don't know what the fuck infrastructure is, where it runs, but I'm guessing like it'll be an Android phone. I don't know, Android phone, internet, But I guess to run on the internet or to run on an Android phone, it's got to go to AWS, Google Cloud, Azure. I don't know. So basically, your front end, your back end, your databases, and then where it runs, your infrastructure. And that's a tech stack. So what you got to know is SQL. I guess Google, what the fuck Google Cloud and AWS and Azure are. That's for the infrastructure. SQL, and then your main coding languages: Python, Java, C, C++, C Sharp. TypeScript, JavaScript, Swift, Kotlin, Go, whatever the fuck. Now, the cool thing is most languages are easy to pick up once you know one of it. It's like real languages. Real languages, once you learn to get fluent in a new language, it's much easier to pick up any other language. So, coding, all it is different words. Languages is a language form of interaction with the computer. But it's different words, different period, colon, star, bracket, int, integer, I, C, char, character, string, uppercase, lowercase, private, public, finalize, try, catch, return, end, system out, in, stuff like that. So language, that's what languages are. The last thing I'll say is how do languages actually work? It starts with assembly. So in your computer, you have a processor, which is the clock, which says how fast commands happen. So a processor says tick, 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 tick. And each tick, it takes a command, it takes a memory location, and it executes the command. And these memory locations and the commands are just ones and zeros. And these ones and zeros go into logic gates, which are billions of them trillions of them in your computer. Billions. And they are the program. That's where the program happens. You can add two numbers together, you can subtract two together, and everything happens like that. For example, when you type on your keyboard, each different letter on your keyboard is just a different code in the computer. 10101101. 1101101101. When you click on your mouse, different buttons on the mouse are different codes in the computer. When you scroll your mouse along the screen and where the mouse pointer is, each pixel is a different code in the computer. The pixels have color. So the monitor provides the color based on the liquid crystals or the screen. But those colors are controlled by the computer, instructed by the computer, and they communicate each other based on 11011011011 for every single pixel. So that's your inputs. And all the calculations happen like that. Storing memory, storing data, a string, a sentence is for each letter a different number. 110 for the first letter, 111 for the second letter, 000 for the third letter, 101010 for the next letter, and in the entire sentence is then stored into memory based on how long it is. Now, if the sentence is too long, you might run out of memory, and that's why memory is a constraint for computers. A terabyte, 500 gigabytes, 100 gigabytes. So it's all ones and zeros, and these ones and zeros are commanded by the processor, which goes how fast, and it's got to do billions of calculations a second. So it's actually more than that. So No, it's billions. It's billions. It's billions. So, uh, each command, like create a number, create a data set, is stored as a 11011110 in the computer, and each clock cycle a new command happens. And that's how you get programs to run, data to store, actions to fire. And they're all done by these logic gates, which are simply 2 inputs, 3 multiplexers have 8 inputs. So you take 8 bits, 10101010, and it transforms into a 1 or a 0 or a 10101010, or it's like a switch, on switch, off switch. True, false, true, false, true, false, true, false. And now it's not linear though. It's not linear because you have something called loops and algorithms. So what that is you can say, repeat this loop 100 times, but change the subject of the loop to shift. So you got 100 accounts, 100 user accounts, and you want to encrypt 100 accounts, or you want to log in 100 users, or store 100 users. So you're going to make a loop that says repeat this command 100 times, but each time shift down the list by 1. So the loop goes the first time, access the first account, store it, encrypt it, whatever the fuck the loop says to do. Next cycle, shift down 1. Repeat the exact same command. Store it, execute it, whatever the fuck it's supposed to do. Next loop cycle, shift 1. So these are loops. And you could program a computer based on the logic gates, the ones and zeros and switches inside the hardware. That's how some machines operate, just hardware, like a vending machine. It doesn't have a processor, right? Or analog electronics don't have processors. Some military equipment doesn't have processors. A lot of it doesn't. So you can command it and make the scheme and program based on just the logic gates and the inputs. So inputs go to the ones and zeros in the logic gates and something happens. But if you're going to do these loops, that's when it gets tricky. Because one loop can repeat 100 times, can also repeat 1,000 times, can also repeat 1,000,000 times. Now, what are you going to do? Write yourself 1,000,000 times in logic gates? You're going to write 1,000,000 times? This logic gate language is called assembly. It's machine language is called assembly, where you're literally commanding the memories and the logic gates what to do. So because big code gets so big and complex, it is hard to read and hard to write in assembly. That's where programming languages come into play. So to write a loop in a programming language can be this big. And we're going to get into that example. You write the variables, you write the execution, and it repeats and it executes, and just that much space in your file. And all these programming languages are read by the machine and get converted into assembly. So they get converted into machine language, and where each transistor logic gate ones and zeros memory goes. So your programming language is higher level, gets converted into the lower level machine language, and goes into the machine into the processor, into the memory, into the logic gates. And that sums it up for everything you need to know from the machine to the lower language to the upper language to the tech stack and the APIs. API stands for Application Programming Interface, which means when you want to communicate with the keyboard, when you want to communicate with whatever device you're programming for, there is a library with all the options that you have features to. So you want to access the camera, you're not allowed to, but you go into the API that you downloaded from the device, from the programming language, and there's a command for what you want to do with the camera. Request permission, turn on, shutter, turn off, zoom in, zoom out. So you request to communicate with the camera, to communicate with the buttons, to communicate with the screen, to communicate with the settings folder, with the files folder, to communicate with your photos folder, to communicate with your internet, with your Wi-Fi, with your Bluetooth. So the API is Application Programming Interface, and that is how the library, your programming language, which is standard, and then the API is different for every single device it's used on. So the API for a phone, the API for a computer, the API for a website, the API for a MacBook, for a Chromebook, for a Microsoft laptop. So the APIs are all different. And yeah. So that does it for how programming works. That's everything you need to know. And now I will get into the language specifics in the next video. Yeah.